Hey, Algebra 1, it is QM1 time. QM1, I can create and solve two-step equations. Yeah, let's go ahead and do this thing. Solving equations, solving two-step equations, one of the most important skills that you can possibly have. That's why we've been prepping for that with the order of operations, with the simplifying expressions, with doing the one-step equations. We've been practicing for this, all right? So we can do many different methods, but here's what I want to start with. We've talked about this already. What is an equation? An equation is different than an expression because it has the equal sign. What it's saying is two things are equivalent. Two things are the same. We can manipulate these things to make them work. Okay. You could do guess and check. Like that's what they're trying to get you to do here. You can guess and check all day and that's fine. If it's too high, check again, put another number in. Let's do it the right way. Let's do it the right way. It's a great, so guess and check's actually not bad when it comes to some things, right? You can use it to get close and see if you're close, but let's see how we do it using algebra. Here's another important concept. We talk about solutions a lot, but a solution of an equation, what that means is you get a number for a variable and that makes the equation true. Think of the equal sign as like a statement. Are these statements true? Do these things actually equal one another? So what we're going to do is use properties of equality. We've been calling this inverse operations too, right? We're using this as inverse operations. So if you see subtraction and you need to get rid of subtraction, you would do addition. We call that the addition property of equality. If you do the same thing to both sides of the equal sign, it's correct mathematically. You can add the same thing to both sides of an equal sign. You can subtract. You can multiply, you can divide, and as long as you do it correct mathematically, you're going to be fine. One of the big things for division, you can't divide by zero. Not yet. If you know how to divide by zero, let me know. We'll make a lot of money. Okay. All right. Solve equations by using the property of equality, right? I'm going to do this. I'm going to set this up like I've been talking to you. Oops. 3x minus 2 equals 6. Now, how I set this up before was if the equal sign wasn't there, and if it was just this, if it was just 3x minus 2, we've talked about do and undo steps. What's the first thing being done to x? Well, I'm multiplying by 3. Then after that, I would subtract 2. In other words, how to undo those things, the last thing that I do is the first thing that I undo. So the last thing I'd be doing would be subtracting 2. To undo it, I would add 2 to both sides. And then I would undo the multiplication using division. So what's that look like? So now we've got 3x minus 2 equals 6. So I'm saying the first thing I need to do is add 2 to both sides. So if I do that, 3x minus 2 equals 6. If I add 2 to both sides, the beauty of this is negative 2 plus 2, so a negative 2 and a positive 2, simplified as 0. This is just 0. So 3x plus 0 or 3x minus 0 is just 3x. Not bad. 3x equals, and 6 plus 2 is 8. We've taken care of this first step here. We added 2 to both sides. Now the second undo step says I need to divide both sides by 3. Well, let's do that. And if I do that, in multiplication and division, I'm trying to get to a 1 times the variable. In addition and subtraction, I'm trying to get to 0 to get rid of it. So I'm trying to get to 1 here. Well, 3 divided by 3 simplifies to 1. This is 1x, or just x, equals 8/3. Now, right there, don't do anything with it. Do not. I can see you're like, I'm going to change it to a decimal. No. I'm going to put it as a mixed number. Nope. Leave it as 8/3. Keep it as an improper fraction. There are times for decimals. There are times for there are times for mixed numbers. This is not one of them right now. I will tell you when those times are. Okay. Leave it as the mixed number, simplified. That's my solution. Okay. Same here. If we look at number 2, part B, half z plus 4. Half z plus 4. So I'm going to rewrite this one actually down here at the bottom. Half z plus 4 equals, I forgot to look at that. Probably should have done that, shouldn't I? equals 10. Equals 10. Again, if the equal sign isn't there, what would we do? Okay, if I knew what z was, I'd be multiplying by half, and then to that I would add 4. So to undo these things, I would have to subtract 4 and then divide by half. And for you eagle-eyed viewers out there, we've been talking about dividing by fractions. Well, what happens when you divide by a fraction, Mr. Brayman? Great question. I hope you've kind of been working towards this. I think most of you have, and that's great. When you divide by a fraction, we use what's called the multiplicative inverse. It's a really long phrase for saying flip and multiply. So let's flip the fraction. So this is the same as multiplying by 2 over 1. Oh, I know what that is. 2 over 1, that's just 2. So let's go ahead. I'm going to rewrite this thing. Half z plus 4 equals 10. Half z plus 4 equals 10. My first undo step, it says I need to subtract 4 from both sides. I get half z equals 6 because this simplifies to 0 and 10 minus 4 is 6. Now this says I have to divide by half, but what I actually have to do is multiply by 2 over 1 or just 2, and I have to do that to both sides. Well, what happens? Well, 2 times half, 2 times 1 is 2, 1 times 2 is 2, and 2 divided by 2 simplifies to 1 or 1z. 6 times 2 is 12. There is my solution. Now you're starting to see, I hope, where this whole do and undo, if I write out the steps, I will always get it right because they're not always going to be this straightforward. This is the most common way that you've seen two-step equations, but we're going to do some tougher ones too. Let's keep going here. So you all, well, if you've had any math with Mrs. Hunt, you should know this top one. What is the goal? To get the x alone. Hey, congratulations. There we go. What is the goal? You need to isolate the variable to get the variable alone. To get the variable alone. To get the variable alone. So you want like x equals something. You want y equals something. You want z equals something. And it doesn't matter, right? A variable is just a placeholder for something. Maybe you want a stick figure. A running stick figure is running really fast equals something. That's fine. That's fine. You want to get the variable alone. You want to isolate the variable. So go ahead right now. This is time to pause and do numbers 3 and 4. So awkward. I never know if you guys actually pause or not. I hope you do. Okay, let's go ahead and do numbers 3 and 4. It says solve by using the properties of equality. I know if I knew what x was, I would first multiply on this side, on the left side of the equal sign. I would multiply by 5 and then subtract 10. So to undo these things, I need to add 10 and then divide both sides by 5. So what happens when I do that? Let me rewrite this. I've got 5x minus 10 equals 20. So my first undo step, remember this right side is the undo steps. I would add 10 to both sides. And if I do that, I'd have 5x equals 30 because negative 10 plus 10, that simplifies to 0. And now, so I've done this first step, I've added 10 to both sides. And now it says I need to divide 5 on both sides, divide both sides by 5. Well, that's great because 5 divided by 5 is 1. That simplifies to 1. It doesn't cancel, it simplifies. Does not cancel, it simplifies. So that's your phrase that you need to email me. It does not cancel, it simplifies. So I have x equals 30 divided by 5, which is 6. How would you check that? I'm glad you asked. That's a really good question. You could substitute this back in 5 times 6, because that's what we said x was. 5 times 6 is 30 minus 10. Does that give us 20? Sure does. Number 4. Number 4 says 1/3 x plus 9 equals 21. Again, when you got the 1/3, when you got the coefficient next to a variable, a number next to a letter, that indicates multiplication. So this is 1/3 times x. I am multiplying by 1/3. Then I would add 9. To undo these things, I would need to first subtract 9. Again, this is our undo. And then I would need to multiply or divide by 1/3. Like we just said, when you divide by a fraction, you need to flip and multiply. So this would be multiplying by 3/1 times 3/1. That's just 3. Okay, let's go ahead and do this thing. I'm going to rewrite it. 1/3 x plus 9 equals 21. My first undo step, it says I need to subtract 9 from both sides. 1/3 x equals 12, because this simplifies to 0, and 21 minus 9 is 12. That's that step done. Now the second step says I need to multiply both sides by 3/1. Okay, 3/1 times this times 3 over, well, I need to write the over 1. 3 divided by 1 is just 3. Okay, and I get this simplifies to 1, or 1x, and 12 times 3 is 36. Okay. Hopefully that's going well. Now we're doing kind of the 3-level stuff. We're doing the word problems. I know what this says. I know it says solving equations to define a unit. But what I want out of this is I want you to be able to take a word problem and first create the 2-step problem and then solve the 2-step problem. Solve an equation to determine the unknown quantity. It says here, in 1963, Dr. Martin Luther King Jr. began his famous I Have a Dream speech with the words, 5 years ago, a great American in whose symbolic shadow we stand signed the Emancipation Proclamation. The proclamation was signed by President Abraham Lincoln in 1863. But how long is a score? We can use algebra to find the answer. I love it. We can use algebra to find the answer. Okay. Let S represent the quantity and years represented by a score. So we're just saying we've got this thing that we've got an unknown. We call that our variable. We're going to use S in this case. Do you have to use S? No, but you have to give units to it. You have to understand what you're getting in the end. And this says S equals the number of years in a score. Well, okay, first we would calculate the years after President Lincoln signed the Emancipation Proclamation. 1963 minus 1863 is 100. It's been 100 years. We've got 5s equals 100 because 5 unknowns equals 100. This is actually a one-step equation. It's not a great example, but that's all right. We divide both sides by 5 and we would get 20. 20 what? Nose hairs? No, 20 years. That was our units for this one. So a score equals 20 years. This is your answer. This is a number. That's a number. This is your answer. Use mathematical writing. Tell me what's going on there. Let's look at an example here. An airplane descends in altitude from 20,000 feet to 10,000 feet. A gauge at radar traffic control reads that the airplane's altitude drops 1.8939 miles. How many feet are in a mile? I know you can look that up, but let's just go ahead and do this. What's our unknown quantity? How many feet are in a mile? So we're going to call that M, the number of feet in a mile. We could have called it G, X, Q, M, whatever we want to do. House, cat, it's fine. Calculate the quantity in feet of descent. He goes from 20,000 feet to 10,000 feet. That is a drop of 10,000 feet. I know that 1.8939 miles was what the gauge showed. So 1.8939 miles is equal to 10,000. I'm sorry, 1.8939 miles is equal to 10,000 feet. So I'm going to solve. I'm going to use the division property of equality to solve for this. Divide both sides by 1.8939. 10,000 divided by 1.8939 becomes approximately, hold on, I'm going to do this in my head. Answers over there also, but I know that there's this number is 5,280. but the solution is right there. That's the solution. You got the number 5,280, but what does that mean? It means there are 5,280 feet in a mile. Here's what you're going to do right now. Go ahead and hit pause. Do numbers 5 and 6. Do numbers 5 and 6. I know these are mostly one-step equations. That's okay. We're going to be doing two-step equations for our 3-level work. Let's look. Number 5 says an ostrich that is 108 inches tall is 20 inches taller than 4 times the height of a kiwi. Oh my gosh, not the fruit. I can see you, not the fruit. Both birds here. What is the height of a kiwi in inches? Okay, an ostrich that is 108 inches tall is, oh, we got to talk about mathematical language here. What do you think that is means? Not this first one. Well, you could take it as the first one, but this one is the one that I'm looking at right there. Is generally, sometimes, most of the time, might mean an equal sign. An ostrich that is 108 inches tall, 108 inches tall, is 20 inches taller, so plus 20, plus 20 on something, 20 inches taller. If you're 20 more, you would be plus 20. Then 4 times the height of a kiwi. What is the height of a kiwi in inches? What's the thing we don't know? I'd look for the question mark. What is the height of the kiwi in inches? I'm going to call that K. K is the height of kiwi in inches. Height of kiwi in inches. So 4K, 4 times that amount, plus 20 is going to give me 108. That's a two-step equation. Hopefully we've been practicing. I know that my first step would be to multiply 4, then add 20. The last thing I do is the first thing I undo. So I need to subtract 20 from both sides. I'm going to rewrite this top one here. 108 equals 4K plus 20. If you wrote 20 plus 4K, that's okay also. Still going to do the same thing. I'm going to subtract 20 from both sides. I get 108. I'm sorry, 108 minus 20 is 88 equals 4K. And if the next thing, if I was doing was multiplying, the inverse operation would be division. And I get 22 equals K, because 88 divided by 4 is 22. Yay! Not done yet, though. We need to say what it is, because this is a word problem. This has meaning. It's not just a number. What did K represent? The height of the kiwi in inches. In other words, the kiwi is 22 inches tall. That is the answer that I need right there. I need this first guy right here. I need you to be able to give me that two-step equation, and then I need you to be able to solve it and interpret it. That's your 3-level type of work. Number 6 says an emu that it measures 60 inches in height is 70 inches less than 5 times the height of a cockapoo. What is the height of a cockapoo in inches? Oh, so many birds. Birds are scary sometimes. An emu that measures 60 inches in height is, ooh, there's that is again. There's that is again. We got this emu that's 60 inches. Is 70 inches less. Ooh, how do I get things less? Mr. Bramey, you do subtraction. Yeah, that's awesome. I'm a terrible ventriloquist. I get that. But yeah, it's subtraction. You're taking away 70 from something. What are you taking away 70 from? 5 times the height of a cockapoo. So guess what? K is the height of a cockapoo in inches. Height of a cockapoo. I have no idea if I'm saying that right. I'm guessing. In inches. Okay. Height of the cockapoo in inches. We're going to call that K again because we can. Again, we could have called it anything we wanted to represent it. 5 times this height less 70 gives me 60. Hey, two-step equation. I know that the last thing I would have done had I known what K was to start with would have been to subtract 70. So that's the last thing I would do. It's the first thing I need to undo. Add 70 to both sides. I get 130 equals 5K, and negative 70 plus 70 gives me 0. Again, addition and subtraction, you're trying to get to 0. Multiplication and division, you're trying to get to 1. Now, if I divide both sides by 5, because that's what I need to do, that's how I undo multiplication. 130 divided by 5, well, here's how I think about this in my head. I can get to 100, I know what that is. 100 divided by 5 is 20. I got 30 left over. Well, what's 30 divided by 5? 6. Okay. 26 equals K. And you can check it. 5 times 20 is 100. 5 times 6 is 30. 100 plus 30, 130. Great. 26 equals K. Yay. Not so fast, my friend. We've got to say what it means. So the height of the cockapoo in inches, the cockapoo is 26 inches tall. Okay. How do you know which operation to perform first when solving an equation? You're undoing the last thing that you would have done. How can you create an equivalent equation by using the properties of equality? Because if you do the same thing to both sides, it's going to turn out the same. Okay. We'll talk about 9 later. Number 10 is what I've been kind of getting at for the last few days here. And here's your job. Your job is to start on the practice. I've given you a bunch of practice problems. It is labeled inside of Google Classroom. Go ahead and knock those things out. Show me that you know the steps. Show the work, show the work, show the work. If you get stuck, use that whole do and undo concept. You guys got this. If you've got any questions, you know where to find me. Send me an email, hit up the live session. Talk to you guys later.